Hi, my name is Arie Cattan. I am a PhD student at Alon University, and I represent our work about realistic evaluation principles for cross-document reference resolution. This is joint work with Alon, Gabriel, Mandar, and my supervisor, Dagan. In this task, we are given multiple documents, and the goal is to find all mentions that refer to the same thing. Here, for example, the entity mentions in blue US President, President Obama, the pronouns his, etc. across all the four documents refer to the same person. In addition, the event mentions in the top documents in green with the verb nominate, names, and also the noun decision refer to the same event, which is a nomination of Regina Benjamin. However, the event mentions name and approach in red in the bottom documents, even though they look very similar to the green cluster, refer to a different event because it's about a different nominee. This task can be useful for many endorsement applications at the multi-document level, including multi-document summarization, multi-question answering, knowledge-based construction, entity linking, and so on. In recent years, the community has seen significant progress in this task, starting with the joint event and entity model of Parameter with its follow-up improvement, and more recently with transformer-based models. And the performance of these state-of-the-art models is higher than 80%, which is relatively very good for this complex task. In fact, we observe that the high reported results don't reflect realistic performance. And this is because of three main reasons. First, models are evaluated only on gold mentions, while coreference resolution also involves mention detection. Second, singletons are rewarded in coreference metrics and can distort results. Finally, models sidestep the lexical ambiguity challenge. Now let's explain how singletons affect the evaluation. To illustrate the effect of singletons, let's start with the typical document applications involving coreference resolution, question answering. To properly answer the question on the paragraph, Anna and Declan eventually make their way on foot to a roadside pub, where they discover the three van thieves going through Anna's luggage. Declan fights them, etc., etc. And the question is, who does Declan get into a fight with? To properly answer this question, we should be able to identify that them and three van thieves are in the same coreference cluster, and then extract the answer of three van thieves. The takeaway from this example is that we see that document applications leverage coreference links to bridge information across mentions. Assuming that the goal is composed of 5 singletons and 2 non-singleton clusters, and the first system identifies all singletons but wrongly merge the non-singleton clusters. On the other hand, the second model is opposite. It performs poorly on singletons predictions, but predicts very well the two clusters with only one single mistake. So, from a coreference resolution perspective, S2 is obviously a better model than S1 because S2 could answer the question, but S1 couldn't answer the question. However, when we include singletons in coreference metrics, S1 gets much higher results than S2, which is counterproductive for downstream tasks. However, when we focus the evaluation only on links, when we ignore singletons like in Cornell 2012, S2 gets higher results than S1 as we expected. It's important to note that even when we ignore singletons, models are still penalized for wrongly linking singletons. Singletons are still valuable and we don't want to throw them out, so what we propose is to decouple the evaluation of mention detection from coreference resolution. Mention detection is basically a span detection task and should be evaluated using spanf1. Coreference resolution is a linking task and should be evaluated using standard coreference metrics without singletons. And when we apply that, we get more faithful interpretation of the results because S1 gets higher results for mention detection, but S2 gets higher results for coreference resolution as we expected. Now let's move on to the last point. ECB Plus is the main benchmark for cross-document reference resolution, and it was built in 3 subsequent steps. The first dataset, ECB, includes partial annotation of event coreference across multiple documents in 43 topics. Later, in 2012, Lee et al. Extend ECB with entity annotation in an exhaustive manner. Finally, Sibulska and Vossen showed that ECB is too simple, and they added subtopics to challenge models with lexical ambiguity. For example, the top and bottom documents from 2 different subtopics of the same topic. And they did that because lexical ambiguity is very common in real-world text. However, since each topic includes exactly 2 subtopics with very short articles, recent work reconstruct the original subtopics by applying a very simple document clustering. And it bypasses ECB Plus goals on sidestep lexical ambiguity, and as a result, model's performance on a realistic use case with lexical ambiguity is not evaluated. To allow more realistic evaluation, we suggest that models will get the entire topic as input without fine-grained subtopic clustering. To empirically show the impact of our propositions, we developed the first end-to-end model for the task. When evaluated on gold benches, our model outperforms the joint model of Eirew et al. Removing singletons from the evaluations leads to a performance drop of 9.9 points. Lexical ambiguity challenge also decreased the performance by more than 9 points. And finally, using predicted mentions caused a drop of 13 points. To sum up, we propose 3 principles to assess drastic performance in cross-document reference resolutions: predicted mentions, decouple the reference evaluation, and evaluation at the entire topic level. Applying our evaluation methodology and a state-of-the-art model resulted in a drop of more than 30 points, which showed a large room for improvement under realistic conditions. Thanks for listening.